So I'm just going to spend more time trying to figure out how VS Code optimizes the file explorer, and I have a bunch of keywords here that I already searched a lot, but I couldn't find any videos exactly related to this problem of making the file explorer load faster. So yeah, there's all these keywords related to it, but none of them uh, are exactly what I'm looking for, obviously. So I think the best thing to do, and like I already have some ideas to implement there to make the Godot component faster, but I think it's probably a good idea to spend more time trying to understand how VS Code does it, and then try some of the things that I'm thinking about trying. I think before I do this, I'm going to talk about an example there on assembly that I realized as I was doing the Yankee cards. So basically here, the number that I put here on this example is this number here, but on assembly it shows this. And the reason why is because it is overflowing the number. So because a very large number, it overflows. And the thing that I thought that is weird is that it doesn't break on the compiler. So if I put one more 9, I think, it breaks and it gives a warning. So yeah, I still don't understand very well. So I asked ChatGPT here, and I still haven't read this answer. But it is kind of confusing to me that the compiler allows you to put numbers that will overflow and not break the thing. So I just ask why doesn't it break when you put the number? But obviously I assume that there's probably a reason for this. I just thought it's interesting that you can have situations where you put a number, like there's a range between the highest positive number or negative number you can put, and then some amount of numbers you're gonna put that are gonna overflow, and then the ceiling, which is the highest value that the type can have, which according to GPT is this number here. And I think I should do the size of the register, just 64 bits. It is undefined behavior, runtime, well-defined, compile. Compilers provide warnings, blah blah blah. So I guess it's just a language like thing. Oh, the other thing that I was looking to this video here. So this is the video I was talking about the profiling, where he talks about this special page on Chrome here. And he also shares, I took pictures, but class 4 profiling using the chrono library on C++. So what I can do is use the chrono library, put the functions, the chrono functions. He creates a class, a profiler timer class, I think, and then creates functions to put on the profiler class, and then it generates JSON at the end of the execution, I think. Then after it generates the JSON, you can put the JSON on this page here on Chrome, and it's gonna show like the time that it takes for each thing. So I might do this, but I'm probably not gonna spend. I'm not really sure. Maybe I'll do this later, actually. And the main thing that I'm trying to figure out now is to understand whether or not the problem comes from VS, or not the problem, the optimization comes from VS. Oh, this is another thing. I basically did a bunch of experiments, like a bunch of different folders to test, and it looks like it takes on average like 9 or 10 milliseconds to load each file. Obviously it's not exact, I just took the count there on Godot. And according to ChatGPT, it seems to be correct. And I also think that it makes sense. So even though it's weird that it takes a very long time there to load, it kind of makes sense because it's still like a large number of files, and it seems to be correct, the amount of time it takes for loading each file. So like on a folder this size, if you load everything and you don't show, it's gonna take roughly around 3 hours to load, even at this speed, because obviously you just do the math, and it's obviously a massive amount of time. But when you use VS Code, obviously it loads very fast. So obviously because of this, I think I just got from Perplexity and ChatGPT, and also thought about some keywords. But basically, I'm gonna open Visual Studio Code with the same folder that I had there, just to see, because it's a kind of a hard thing to test to see if it is low. Because what I think that VS Code is doing, they load like only the first level of the folder, and after they load the first level, they progressively load on the background the remaining folders, and then as you interact with the File Explorer, it loads whatever you need at that moment. So that's the way that I'm thinking about trying to implement on Godot. So like I was thinking about doing breadth first search because of this level thing, because I think breadth first search is gonna allow you to load the current level of the folder first, or very fast, because you only need to if you do that for search and emit a signal to load the folder, then it's very likely that I'm not gonna have the folders on the same level. I'm just gonna have like, it's gonna be def as the name says first. So it's not gonna give the like illusion that is loading the folder. So I'm thinking about changing to breadth first search, and then you load the first level, or you put based on time. So this is maybe it's a better idea first to, I guess I'll have to change the name of the string, but I think I might just do a Python script, like a simple Python script to create a bunch of folders on uh, another folder, or a bunch of files, empty files, to see if VS Code is going to load them fast. So when I load this massive folder here, it loads everything right away. So this is the thing. So based on that timer there, I think that it is correct what I was saying. I think it loads. Yeah, so now, so I'm pretty sure that this is correct. So it loads everything. So like right now it's probably still loading. So as you interact, it loads, and then they put this icon. So just because of this, I already know for sure that this is what's happening. But I'm still curious to see what would happen if you have a folder that's. So I think I'm gonna do that before I. The question is where I should create this thing. So I'm gonna just ask ChatGPT or something, or Perplexity to. I'm gonna create another folder here. So if I remember correctly, let me. I think you have to do virtual env, then venv to create a virtual environment. And what I'm gonna do is just see, I'll create a simple script to create a bunch of files on the same level. And I want to see what's gonna happen when I open the folder on VS Code. So I think it's virtual env, venv. To create the virtual environment, then you activate the environment by calling the following set of the script. So it's gonna be venv. Yeah. is with open. The problem is, okay, so for loop. I guess if I use if open, is not gonna, with open is not gonna, so I'm just gonna ask shape it there. Up there, nine. Yeah, let's just test this. So I think all I have to do is run. Sure. I'm gonna try to open first from here, and then I'm going to go in the on here, then go into the folder, and then try to open VS Code. Maybe I actually it's better to initialize VS Code first instead of opening from the terminal. It might take a long time actually. It did use with open. Oh yeah, it's create a new one based on the name. So I wrote down there is some stuff on the documentation there on VS Code on their GitHub repo that briefly talks about file systems, and these are basically the keywords that are got. So they use this file watcher and this system provider to look for changes and stuff like that. So I think I'm gonna probably see if I can put the breakpoints on these classes, and then just step over. I think the main priority first is to figure out like where are the optimizations coming from. This is the part that is hard to, and I couldn't find anything related to this. I just found resources that briefly talk about, not briefly talk about, but resources that talk about other stuff. It's not very, it's because of C++ as well. That the challenge is, so for example, I watched a lot of videos about the infinite scroll on the browser, which I think is a similar problem because I think fundamentally the issue is whenever I have a bunch of data, there's gonna be techniques to optimize how fast the data seems to load. And it's the same thing that I encounter on React, which I think is a very common problem, is the loader thing. So I forgot the name of the component on React, but I think it's something related to a fallback. It is a component that has a fallback as a props, I think. So there is a special component on React that allows you to put the loader icon that shows up as the data is being as the server is sending the data, from what I remember. So, but the thing is, I forgot the exact names on React of the component, and I also forgot the keywords, and also most of the resources that you're gonna, like most of the videos you're gonna watch, the problem is that they're not gonna talk about the fundamental principle. They're just talking about how to use the component, which is understandable because that's what most people want to search for. But obviously, I'm much more interested on the first principles behind the pattern. So what is going on when you're actually implementing the component on React when it comes to the server, and how it determines, like, how does it implement the optimization of what you show. And there are other, the infinite scroll is another one, but then most of the video, all the videos talk about libraries, but they don't explain how the library works and stuff like that. And the problem is that it's not even what I'm trying to do. I'm trying to do on C++ and a different thing. So I'm not really sure if it's worth it to spend the time as well to, like, try to understand these libraries, because it's like, it might not be the best way to understand the fundamental principles. So I think that the fundamental pattern is loading massive amounts of data progressively, and then figuring out the optimal strategy to do this. And I'm not really sure if I'm like, the thing is, I might be overcomplicating, because it might be very easy the way that I'm thinking about, because what I was thinking about doing is just emitting the I think the main thing that stops Godot from showing the files in the beginning is that it waits until all the files are loaded until it emits the signal to the other class. So it's like a client-server relationship between two Godot nodes, the way that they design. So the editor file system is the backend, which is the server, and the file system doc is the client that's going to show this stuff. So the way that they design it, the server has to load all the data, and then after it does that, then it emits the signal to the client, and the client displays the information. So I think that, like, the path to make this better is to put some heuristic inside of the function that traverses the directory, so that based on either an amount of time or an amount of files, it sends the signal to the client to display everything. And then after, it continues to work on uploading the directory, and then you create some cache you create a cache on the server, which is the file system class, that determines what files were already loaded and what subdirectories were already loaded. Because that way, when you interact with the file system on the front end, which is the doc, you can determine whether or not the file wasn't loaded. If it wasn't loaded, you send the signal to the server again, and then the server figures out a way to load that file first. So I think that the challenge comes on creating multiple threads to make it faster, and also to synchronize the threads, and synchronize the threads based on the requests of the client. So, like, because as one of the threads is still traversing the directory, after it emits the signal, when the user sends the signal, that thread has to synchronize the data with the new one that is going to start to work on the current project, or on the current directory that has to load. And then they have to, and I think that the way that they synchronize is based on the cache. So that's roughly the way that I'm thinking about trying to implement this on my mind. But obviously, I think it's better if I understand how they did it here. And I also think, like, because it is a fundamental pattern, and it's likely that they encounter problems that I might not be thinking about. So, but if it takes a massive amount of time to try to understand this, then I might just try to implement whatever I'm thinking about now. Damn, this is taking a massive amount of time. Yeah, so it is gonna take a lot of time to open. So I think that there is no secret to this. And also it makes sense. So yeah, because obviously like it has to be slower from like a yeah. So like from a physics perspective, it has to be slower on VS Code because there's more barriers until you get to the hardware. So it's like just because of the fact that it's using TypeScript and then it's using Node.js to communicate with Electron, and then Electron has the C code, it means that it should be slower. So like the main difference is obviously going to be on the optimization. So it means that, uh, but it's just like a weird thing because I think it's because I never opened a very large file on VS Code, so I never saw that taking a very long time to load anything. So I think that's why it was kind of weird to me. I expected to be able to load a lot more files faster. So I'm gonna start. I'm gonna have to close this because yeah. So I'm gonna search for this other. Let's probably close this as well. So I'm gonna show you then if I want to see this again. I just look into the stream again. 21 minutes. So I'm gonna close this. I'm gonna search for these other terms here, and then I'm going to put some breakpoints, and then I'm gonna start stepping over or stepping into. And I'm probably gonna use ChatGPT to try to figure out. Already know that the Explorer model class is one of the main classes, and then file service is another main class that they use. This is probably one of the most annoying things about TypeScript, that it goes to the declaration. It's very annoying. So whatever. So I'm just gonna step over. I need to clarify exactly what I'm looking for. So I'm pretty sure, like I think, I'm like 70 or 80% confident that the optimizations are on VS Code parts of the code, but there might be, there is a chance that there are things that are related to Electron because of the stuff that I said. Like on the specifics of the implementation has to be from the TypeScript on VS Code because obviously uh, Electron is just a framework, but when it comes to like the optimizations on like how fast you render, there might be some stuff like related to the amount of data and then using Node.js because I assume that's uh, almost 100% sure that Electron uses Node.js. So the way that the Electron uses Node.js and the amount of data, something related to like the amount of data you have after a threshold, Electron might implement some stuff that in order to make it faster to communicate with whatever application is running on Electron. So imagine that this is the relationship. Like you have a like Electron would work as a server, which is just the bridge between the TypeScript codes and the driver. So obviously there is communication between them, and then I think that the nuance is going to be on directly correlated with how much data you're passing back and forth between the two. So assume that there might be some optimizations. But I think that's probably most likely coming from VS Code's source code. I already stepped into this last time. It does look like it goes over this function here, and that's the function that is used to load everything. So it's just a map. And also I was gonna put a breakpoint on this thing here. So set roots is a function, and it calls the function later. And this creates the item. It maps over the folders from this workspace. So you can see. So once I hit this breakpoint, I have to see what is the contact servers, and then get the workspace. So this is another thing that is kind of not really sure if confusing is the best way to put, but I think the caching is also important, I think. But it doesn't seem to be very hard, that's the thing. Like based on the stuff that I was seeing there from the video of the guy, the optimization when it comes to caching is you should prefer to use vectors and arrays, and you should prefer to use data instead of pointers. And the reason is kind of obvious is because when you do those things, the data is located in the same place in memory. So it makes the CPU, the cache work better. When you have other data structures, the data is going to be fragmented, which is going to make it harder to cache. But it doesn't seem to be very hard to implement. But assume that this part's going to be very different from VS Code, then I'm going to implement there, obviously, because they save everything on JSON, I think. And then based on the configurations, I think once they load the folder, they change the configurations, and then from the configurations, they decide what files should open. So here, when they are on the Explorer model here, the context service, I think on the workspace here, they're gonna have the folders. So I assume that the first time you open is going to remember from the configuration of the last time, and that's gonna contain the folders that has to load. So this is the folders that is mapping here. And I assume that once you open the folders for the first time, it's going to save the stuff on JSON files. And this is the function that gets called there, which is the recursive function that is gonna create the directory. So like the weird thing, I think this is the first, like one of the main things that I'm trying to understand, because like it doesn't make a lot of sense to me that uh 'cause there doesn't seem to be anything here on this function that is going to like make the thing load. Uh, so I assume that the only thing that makes sense is that it's gonna call this function from an asynchronous function, or from it's gonna use async at some point to call this function, because that's the only way that you would be able to do the work at the same time. Because obviously here there isn't anything that seems to make the thing load as like it's traversing the directory. So I think that's what the thing that I have to understand is like how can it display the folder in the beginning and still continue to load on the background. So that's the but figuring this out. So I'm probably just gonna ask ChatGPT before I start trying to step into, because maybe it's gonna have a good answer for this. But the problem is like, what is the best way to ask this? Let's search for our file service. Explorer service. Yeah, so I think first, the other thing that I have to, I'm probably gonna write this stuff here. I need to remember, I can, maybe I do this first because I want to remember, I'm gonna write down the keywords here. I want to remember on React. Yeah, so I'm gonna, what is the name for the thing that displays the loader icon? I'm not pretty sure how to, like the best way to phrase this, so I'm just gonna asking, because it's probably gonna have an answer that's gonna give me the keywords to search. Long time to load and language to display loader icon. What is the name of? A lazy loading, I think is the, and I already have a bunch of keywords on this. But there is a specific component. So I'm gonna ask for libraries. Oh, suspense. Yeah, so I guess like this is the thing that I'm gonna write down here. Because the problem is, if I search for videos, I think that they're just gonna explain how to use it, but I want to understand what is going on in the background, under the hood, how this stuff works. But I think I might be like overcomplicating on it, like it's probably the way that I was thinking about before that I was explaining. It is just gonna be like it's gonna be some control flow that determines like based on heuristics the like what actions to do based on how much data you have and how long it takes to load that data. So I think usually it's probably gonna be on time. It's based on time, not based on the quantity of the thing. So I'm gonna search for the components source code. We're just gonna ask perplexity. Oh, I think I found the GitHub. Not sure if this is the official one. It's one of the first links there that shows up. There's also the React query, I think, which is probably related to this stuff as well. But I think React query is for something different, but I don't remember really well. Yeah, I think it's for search. And there is also other stuff related to search, which I think that like from principles perspective is going to be the same problem both on search and on loading, just different applications of the same thing, which is basically the amount of data, how to load large amounts of data progressively. And this is another one of the reasons why I was thinking about the scroll on the infinite scroll on the browser is because I'm probably gonna have to try to implement something similar. So this is the reason why another reason why I was curious about this one level folder on VS Code, because the way that I was thinking about it is to implement in the same way that they implement the infinite scroll on browser, which I think that and this is the stuff that I'm trying to find keywords for, but it's very hard to find videos explaining the fundamental principles that don't use libraries and stuff like that. But I think like the way that they do it is that they have a window of what's going to be visible on the screen, and then they probably have a range outside of that window, so that is not slow. It doesn't become slow when you go outside of the window. But as you scroll, then it shifts the window, and then they manually load and delete data according to the movement of the window. So I think I might have to implement something like this as well. So when the folder is too big that it opens the scroll, then it should or it has to be both when it's too big that it opens and the folder has a lot of files. But I'm not really sure if it's worth it to implement this. That's why I was curious just to if they have something like this on VS Code. It might be worth it because I think that's yeah. Even if they don't have on VS Code, I think it might be worth it to do this because it is kind of annoying on situations where you like for example you have large amounts of CSV files for example on a directory, then it becomes very annoying because you can't look into it. So the question obviously is let me see here. Yeah, so here they show, and you can see that it's still loading. So I wonder if I do this. Yeah, it still allows you. So I imagine that so maybe looking for kernel implementations might be like a better way to find. Yeah, maybe it's probably. I think it's probably better to search stuff related to kernel instead of the VS Code thing because it's already gonna be on C++, and I think it's closer to what I'm trying to implement. So maybe a file system implementation on the kernel or something. But I think here they are doing what I was talking about. Like it probably only loads the data where it's visible to with a certain range, so that it's not slow. Hmm. Also, suspense, according to ChatGPT, is gonna be on the React DOM. It's parts of React. And so now I just realized this. Maybe it's not very good. And the question is whether or not you can find content related to this. Because if I can't find the content on the file system from the operational system, I think it's going to be a lot closer to what I'm trying to implement there. So imagine it's basically the same pattern, like it's exactly the same thing. And on the front end, on the browser, it's just going to be the same thing, but with extra layers. That is the framework on JavaScript and like the library. So it's probably much better to study the file system instead. So I'm gonna ask ChatGPT. I'm gonna create another chat. Yeah, I think that this implementation makes a lot more sense as well. Like if I could implement something I still haven't decided if I'm going to keep I probably should just. Yeah, I'm gonna change actually because on the Godot components, the way that they have is on the same level. Like they have a tab there to search for files and folders. But I think it makes a lot more sense to do the same way that VS Code does, which is basically another icon on the sidebar for searching files. So I'm gonna remove from the main one. But I think that the difference is probably gonna be I should try to implement something that is closer to this thing here as well that shows the loader. Because initially the Godot has a class which is the progress bar, which the normal editor file system uses, but they create another component to display the progress bar. So I have to see if it is possible to show the progress bar, yeah, on the same place that they put the path there. I think that's probably what I have to do. So I could change the way that they display the name so that displays the progress bar instead, but it also displays the name. But I think the way that they designed the progress bar is just show a percentage instead of showing like just changing the background color. So I'm gonna have to see if it's possible to do this. Actually, I might. I think I'm probably gonna change what I'm gonna do. So I think I'm gonna change the title of the string later. Because now I think that this is gonna be far more productive actually. It's a lot easier to like it's a lot closer to what I'm trying to do. And it's also better, like a better implementation, I think. So I should probably do this. So the question is which one to study? What is gonna be? So I'm gonna ask. Let's see something. So saying dolphin. I assume is Linux. branch or however you say that. Not sure. He's on C++ as well. Yeah, I'm gonna spend time studying this stuff here. Because I also already had the plan of studying operational systems. And I was already, I spent a bunch of time watching videos and I was gonna read articles and I was doing more stuff like that. So I think it's just gonna kill two birds with one stone. I think it might be, so obviously I'm gonna focus mainly on the stuff that I'm trying to figure out. But I think it's probably better to do this than to study VS Code. I'm gonna spend 1 hour studying VS Code still because I'm kind of curious. So maybe today I just spent 2 hours studying VS Code, and then I study this stuff later. I'm gonna read what ChatGPT is saying. I use this Qt framework. Also, a long time ago, I bought two courses on Udemy. I think it's Udemy, the name. But ended up not finishing because I didn't like it that much. But I might go back and finish. 'Cause the thing that I didn't like about Qt is that I think it's mostly from the course is that the guy was using Visual Studio, and for the building it's kind of annoying. So I'm not really sure. Probably the best way to try. I should probably try to build this stuff, but this is another thing I'm not 100% sure if, like, if you need to have like a virtual box to test this stuff, or if you can, like, how does it work? I'm gonna read this stuff. So I'm gonna close all this stuff. I think that is probably a lot better. It makes a lot more sense to spend time trying to understand how they do it. How they do it. It might be. I might have to choose another one though because Qt might be like might not be able to look into their source code. But I think that even if I can't look into the source code, I think that's probably gonna be like very similar the implementation because they probably use Qt. The optimizations are gonna come from the way that they use the framework, and I assume that I can do basically the same thing on Godot. It's just gonna change like the way that I interface with the API. Because on Godot, it's gonna be abstraction built. So on any framework, I think the way that it's gonna work is that the framework is just gonna be basically an abstraction that interacts with the operational system. The operational system has a built-in library to create the visualization. So the main difference between the frameworks on C++ and any other language on how they are going to implement GUI for desktop apps is going to be on the abstraction that they built to interact with the operational system. So I think that even if I don't have access to the code, it's probably very likely that I'm going to be able to study their code to understand the optimizations that they do, and then I can try to translate them into the stuff that I'm doing there. And it's gonna be very good as well because it's gonna get me thinking on how the operational system works. It's gonna clarify more things. I kind of already have a very decent idea, I think, but when it comes to the nuances, obviously there's a lot to improve. So the question is what is the best place? I'm gonna obviously use ChatGPT again. Also, I don't understand why people uh, don't use ChatGPT or LLMs because they hallucinate. Like, it doesn't make any sense, sure. So It's so much easier to search for stuff and learn when you have access to the LLMs. It's a lot better to search. It's kind of funny to me that people don't want to use it because it hallucinates. I'm gonna close all this stuff here. I'm gonna put a timer there, and then I'm going to spend some time studying VS Code, and then I'm going to try to start studying this other stuff. I'm gonna see if it is possible to build first. So I'm gonna download the source code here. Actually, it's probably better to try to like figure out the documentation. So I'm gonna use ChatGPT uh, to like try to organize the best path to go about studying. So like figure out the documentation and stuff like that. And I'm gonna see if there's a way to build the code for this Dolphin, which I think is a Linux distribution thing. It's like a variation. I'm not really sure what's the best way to say it, but it's kind of like a variation of the Linux implementation, which is just operational system. So the operational system is mainly a kernel, which is a software that is going to interact with the hardware, and it's going to be a GUI library, and it's going to be systems libraries. So, and the main thing that the kernel is going to do is organize the execution of processes and the privilege rings that you have. And the GUI library is going to be the thing that draws this stuff. And I think that Dolphin is just going to be basically the kernel and the GUI stuff. And I think that the kernel is just like a. It actually sounds a lot more complicated than it is. I think, because it's just going to be a bunch of C++ or C structs that tell the hardware what to do, and they're going to do that based on the instruction set architecture, which is the interface between the software and the hardware, which is just the encoded instructions that they put on the hardware that you're going to use on assembly. So yeah, it's just like any other C program, I think, an operational system. So I think it sounds a lot harder than it actually is, sure. But obviously, there's a lot of stuff here, so it might take a long time to understand everything. So I'll be right back. I'm going to spend some time studying VS Code. Then I think I'm gonna put on the RNG how much time to study on each thing. I'll be right back. Then I'll decide what to do. Okay, so I'm going to spend just like probably 1 hour and a half studying VS Code or going over VS Code. Then upstream, I'm going to spend time trying to figure out. Uh, but I'm probably gonna just try to understand how I'm gonna focus on the dolphin thing. I think I'm gonna spend more time trying to see if it is the best option as well to try to understand. 'Cause there might be one that's closer to the way that Godot is supposed to work. But I'm gonna spend more time searching for the file explorer when it comes to the implementation on the operating system instead of VS Code. I think it's gonna be better, and they are probably optimized, I think. Like I assume that the Dolphin and other Linux variations are gonna be similar to this, where it's gonna allow you to open large directories at the same time, and the way that they do it is based on optimizations. So yeah, I read this stuff. I think it's probably gonna be better to see if I can find videos first. So usually the way that I do it, and I talk about this all the time, but I think it's worth talking about, is I think about it in terms of a funnel. So like I try to reach breadth of knowledge first. So watch a lot of contents and read a lot of things very fast without being concerned if I understand everything very well. Then after I do this, I have an idea of what are the most important things and what should I focus on the most, and also what channels I think resonate most with me. Then after I do this, then I spend a bunch of time going into depth from the resources that I think are the most useful ones. So it's probably the strategy that I'm going to try to implement here as well. So I'm probably going to use Perplexity and ChatGPT to first find keywords that are relevant, then find the content that is relevant to this thing, and then I think first I'm going to see to make sure that Dolphin is probably the best thing to look for. which I think it probably is just because it's on C++, and I think it's gonna be the easiest one to translate. But I'm gonna spend more time just with Perplexity and ChatGPT to see if that's the case. Then I'm gonna search for content for videos and a bunch of channels, watch a bunch of content, read articles and stuff like that. And then after I have a good idea, then I'm going to probably try to build the project and then start maybe try to build to set up the debugger, see try to figure this out. Then after I do this, then uh, go on the source code. And if it takes too much time, then I'm probably just gonna try to read the source code right away to and then focus on the parts that matter the most to me. Okay, so I'll do this stuff later, and I'm gonna start stepping over this. So I'm just gonna press F5 until I get to the point where it loads the thing. Because my main focus is to understand the optimizations around the file system or Explorer tab. And now probably try to I'm not gonna try to translate what they do here to what I'm doing there. I'm going to focus on the operational system probably. So I'm just gonna continue to step over out of curiosity. I'm also gonna close the stuff that I have. So this is an idea that ChatGPT gave me as well, which is to search for the issues here and search for keywords on here. So I was gonna do that, but now I think I'm probably gonna remove all these keywords here as well, and then just put stuff related to the operational system there. It's probably gonna be a lot better to understand things. I'm just gonna remove this stuff uh, later. Um, I was reading the electrons documentation as well. Also got into their Discord server and I put a question there, so I'm probably gonna remove as well. I'm just gonna close this stuff. So I'm gonna press F5 until I get to the point where it's gonna load. Or after it loads the application. Already put some breakpoints. Yeah, so this is the first part that it loads the main thing. And this class is the main class. And then this function here is the one that initializes the server. So I'm gonna stop into it a little bit, I think. So I have to remember the name of the. Let me open. Let's see if I can. Explorer model is context. So this is the one that I'm trying to. Let's see if there's. There isn't any name that is similar to context here, so I'm just gonna go over. So otherwise, it's gonna take too much time to go over all of this. But I do remember going over some time ago. So maybe I would try to see. I should have step into this because this one is one of the ones that is related. So if I was service, I think there isn't anything. Maybe the disk actually, because this is the other class there that they had on the documentation. So obviously, I also think is related. This file. I wanted to remember how does it create the proxy there? There is a part there that is weird where it creates a bridge between this code and whatever code is gonna run later. But I don't remember where exactly. There is a part that is kind of weird. So I'm just gonna step into. There isn't anything interesting. This function is interesting. So it is coming from this file system provider, and it's interesting because of the lock. There's also a comment there that I saw that one of the classes they say that ensures atomic read of data or something like that. Atomic just means that the executions are gonna be done all at once. It's gonna read, it's gonna write and read, like not the same time, but like it's gonna prevent other threads from accessing the data or doing anything with the data. So it does everything on the same cycle, let's say. No, it's not really on the same cycle, but like it's more like it does things together. Not really sure what's the best way to describe this. Every time that I read Atomic, I remember from Ethereum, from Solidity. I think that's probably the easiest way to understand atomicity is when it comes to Solidity execution of contracts. It's like on Solidity, when you use an atomic instruction, it does several transactions at the same time, let's say. So it batches everything together. It's basically the same thing that's happening on the when it's atomic on C++, let's say. It just means that you're gonna do everything together. But I'm not really like I don't know for sure, but I think that's not. It doesn't mean on the same cycle necessarily. It just means that you're gonna execute this like the things together. So this resource lock I think is related to this. Like it's gonna lock the data so that other threads don't mess up the data. So I think that this is probably like one of the functions that is related to the optimization there on the file, in the file system. The true disposable stuff is kind of hard to understand. Most of those classes they inherit from the disposable class, and it seems that the disposable is gonna have a dictionary that or a map that is gonna be used to track events as well. It seems that it puts events. There's a class there that has a function that to put events on the disposable, but I'm not 100% sure what is the point of having that disposable thing, like this function here. It seems to be used a lot, obviously from what I've seen just now. And this barrier, I assume that is basically a very similar class to what the mutex would be on C++. And then this just keeps track of the locks. So it works like a fence or like a semaphore that you put a barrier the moment that you want other threads to not access the data. Like you're putting boundaries basically between the execution. And the reason why you do it, one of the reasons is because, one of the reasons to use this is because there's optimizations that happen on the compiler and on the hardware to reorder instructions in order to optimize the amount of work that is done per cycle. So on this reordering of instructions, there could be a problem with data, which I think the name that people say like, it's hazards or variations of hazards. So it would be a data hazard. And I think like programs don't execute instructions sequentially. They execute like the instructions don't have to be sequentially executed. The data has to have sequential consistency. So for like the order of time, let's say, that the hardware thinks about, the only thing that matters is the data and not anything else. So this sequentiality, let's say, of the program is mainly determined by the data and not anything else. So the flow of data is the stuff that matters the most. I'm gonna skip this functions. Just gonna transform that into like a standard path. It seems that this is related to the settings now, but I'm still curious to see how it works. Yeah, so we translated the path to the Windows version. So it's basically putting the locks on the cache, and then if the locks exist on the cache, it's going to call the one of the functions from the lock, which is basically the wait. It's probably a loop or something. Existing lock, it tries to get, and if it doesn't exist, it creates for the first time, and then it's gonna call this function with a callback, and it's gonna call this open here, complete promise. So assume the open is like the release on the, I think it's release on the mutex. No, it's load. Yeah, so load is like the release on the C++. So you have load and store. The store is gonna be when you lock, obviously because when you want to write the data to the place, and then loads when you wanna get the data. I think this is just the type, doesn't have the function. I think like after learning Haskell, I understand more why it is annoying to me about this stuff about TypeScript. And the reason why is like on a language like Haskell, it makes sense to have the types the way that they are. But the reason why it doesn't on other languages is because other languages have side effects. So the biggest difference between functional programming and object-oriented programming is that functional programming doesn't have side effects and the data is not mutable. So because of the fact that object-oriented programming and procedural programming are going to have side effects and the data is mutable, it makes a lot more sense to understand what is going on inside of the function. Because just by looking at the data here, like there isn't much information that you can see from this unless you can guarantee that the only thing that matters are the inputs and outputs from the function. And that's the main difference. So this is the reason why it's kind of annoying to look into the declaration, because like just by looking at this, you can't really know for sure if nothing is gonna happen inside. So the main key of the issue is the side effects. But at the same time, I disagree with people on functional programming that say that this is like it's like anything in life. There's gonna be trade-offs, and the only functional programming is not going to be enough to capture the full scope of space-time. So I assume that there are a lot of situations where you do need to have the side effects and mutable data, and Haskell gets around this with the monads. But I think that even like the monads are not going to be enough. I'm not 100% sure about the nuances of when it's going to be, which situations are going to be necessary to have side effects and mutable data, but I'm pretty sure that has to be the case because it works as a gradient and the complexity is going to be somewhere along the range. So I think on situations where you have a defined thing where you're mainly transforming data structures through the execution of functions, which is basically functional programming, then it makes sense to do things mostly based on the types, because you can guarantee that what you're seeing is what you're gonna get, and it's not gonna affect the global state. So I think that on Haskell it makes a lot of sense to the way that they created this stuff. it's very confusing to understand, and it's still like this is one of the main things that I'm struggling the most to understand on Haskell because the it's mainly ad hoc polymorphism that is kind of weird to understand because it's the main thing that is different from Haskell than it is from the other languages. But I think that's one of the reasons why it's probably very good to learn Haskell because it's so different than the other ones. It like forces your brain to expand. So like the biggest thing that I was trying to figure out today, I was watching some videos on Haskell, and I still don't understand very well. Is like how does it work when you're implementing like the product types? Like what is the main difference between the type constructor and the data constructor? And those are like what probably the thing that is the most confusing. But it might be because like there is you need to understand the implementation of the compiler, the Haskell compiler, to fully understand like what it means. Because like on my mind, the data constructor would be just it would be exactly the same as the type constructor, but it works for built-in types. Because if you think about it, like what they call data, is just gonna be like a built-in type. So it would is like example would be an integer or a string, and then the type constructor would be just a constructor of built-in types. So they are essentially the same thing, but they operate on different levels of abstraction. But it's very confusing to understand, especially like how you're supposed to do it in practice, how you're supposed to use it. And this is probably the main difference as well that I can't quite uh, think about words or stuff like ways to search for this. But like the it's very different because it seems more like I think that it's just confusing because they use the name class, but for types. So it's weird because when I think about the type classes in Haskell, I associate with normal classes on C++, but obviously it's fundamentally different. Like the type classes are closer to the way templates work. So like there are more classes to determine behavior based on types. But on the normal classes on C++, is going to be more about determining the structure of memory on. But you're still having the types because when you create a new class, you're gonna is basically the same as creating a type. So I think this is the thing that is kind of confusing because it is very similar, but it is different. And doesn't allow me to. I know there is the other functioner, but it gets kind of confusing. So disposable is a function. I think that the thing that is confusing is kind of like bridging the gap on Haskell. So I think this would be like an example of what I'm talking about. That I think that type classes on Haskell are closer to like this dynamic here. Is more like structuring the type and not the class. But then what would be the difference between creating a class and creating a type class in Haskell? So the difference between type class in Haskell to a normal class on C++. And I think this is related to the stuff that I was talking about before, about the side effects and mutation. That's why I'm trying to clarify this on my mind. Because I think that's is basically the same thing. The reason why there's a difference between like the class on C++ is intrinsically connected to the type, to types, because every time you create a class, it's like you're creating a new type. But it's fundamentally different than the way that the template types work, because like the paradigm on Haskell is more about how the types are going to be translated using functions. So because you know that the black box that is the function is always going to be deterministic and it is not going to have side effects, you are mainly creating like pathways to translate the types, and that's mostly how Haskell works. But on C++, because you have side effects, you're not mainly translating types. You're translating the state of the whole thing, the whole program, every time that something executes. So there's both the translation of the types, but also the side effects. And I think that's what makes it different in the way you think about it. But on that range, I still haven't like I can't think about very good ways to search for stuff that to clarify exactly how the thing like is almost on like on my tongue, let's say, but I can't quite uh, think about a way to ask these kinds of questions. Like it's kind of hard to think about like how to ask this. What exactly is there is a difference there between like the normal class and the type class. So what exactly is the difference? Because they both change, they both determine the structure of data, and they both have functions. So they both change the behavior as well. They, but they are fundamentally different. That's the thing that is very confusing. I'm gonna press a 5 here. I think I spent too much time on this already. So I'm gonna try to get to the. This one also I think was important actually. Or maybe it's because of another part. I think that the difference might be it's almost like you have two different layers of programming. Like the time classes would be more like a meta programming. So like it is closer to the templates on C++ because of that, I think. It's like you're programming on the way that you program. I think that's why it's very confusing to understand. The classes are more related to the execution of the program, and the type classes are more related to how the program thinks about the execution, if that makes sense. Yeah, because I think that that's what makes it hard because it is kind of like you're incorporating the black box that is the compiler. That's the reason why it's difficult to understand because it is the same on C++, I think. Like when you're dealing with the because I think the C++ has concepts which are supposed to be the equivalents as of Haskell interface or instance, which is the implementation of type classes, and it's called ad hoc polymorphism, the name. But I think that's when you're thinking about templates and type classes, like it's more about how you have to understand how the compiler is going to resolve the relationship between different classes, between different types. I think that's the fundamental difference. So when you do template meta programming, you're thinking more about how the compiler is going to resolve the types on runtime. And when you're thinking about the implementation of classes, you're thinking more about the structure of the data and the behavior of the data. Yeah, I'm gonna press F5 there. Specify how much times. I have to remove because it's just annoying. It's taking too long. I'm gonna have to wait. He's giving this warning here. It's the same thing that happened last time. It started giving this warning or this error message after I selected the folder there, the big folder for the first time. Before it wasn't giving this warning or this error message. So I assume that it's something related to the settings that now every time it gives this message here. But last time I remember that I waited and then it worked. So just gonna wait to see what happens. And the main thing that I have in my mind right now is, which is kind of annoying me, since I started learning Haskell, is the relationship between classes and templates, like classes and types. But I'm not really sure. It's annoying because like I intuitively get it, what I'm trying to clarify, but I don't have the words yet to search for this or describe what I'm thinking about. Like the point that is confusing. So I'm trying to think about ways to clarify on my mind exactly. And I spend a bunch of time with ChatGPT as well, trying to like talk to it in different ways to see if it allows me to clarify what I'm thinking about. But I couldn't, like, it's more clear to me now, but it's still kind of weird to think about it. So I'm not sure if this is gonna work. Maybe I'll spend some time asking ChatGPT. Like I said before, I'm pretty sure now that what I'm gonna do is just focus on this. I'm not gonna use VS Code anymore, I think. It's probably gonna be better to study this stuff here. So I'm gonna spend some time, I think, asking ChatGPT stuff related to types in Haskell. I think it's templates like this. It might be bad because I'm asking like different things at the same time. So it might be better to just ask the first parts related to C++ first, then ask about Haskell, but I just want to see what it's gonna say when it comes through everything. I think that the easiest way to put the point of confusion is how to draw the distinction between what is considered to be a type and what is considered to be a class. At what moment those things become different from the compiler's point of view. And that's what I'm trying to clarify. And I think that it is confusing because it's fundamentally different on Haskell than it is on C++, the way that the relationship works. Because in Haskell, you don't really have a class. You just have type classes, which are more similar to templates, as far as I understand. But the difference between the type class and the template would be that the type class allows you to implement different behavior depending on the type, but it is still not a class the way that the C++ would be, because it just related, it's just specifying the how to convert the types. And I think on C++ is more the class specifies how to structure the data. Yeah, so I think that the main difference is probably on the relationship between the way that the data works. So like when you create a class on C++, you're creating a type, but yeah, you're creating a type and you're encapsulating the abstractions you're gonna put inside of that type. And then the way that the type is gonna relate to the external program is only gonna be through inheritance, which follows a subtyping mechanism, which is just the base class is gonna have the bigger set, which is the type that encapsulates everything, and then the inherited classes are gonna be subtypes from that. So the compiler is gonna be able to derive the types based on that. And if you're passing the data, it's gonna have object slicing, which means it's gonna cut the behavior because the derived classes implement more things than the base classes. So I think that's probably the biggest difference. So like a type class on Haskell is basically it is also implementing behavior, but it's implementing the behavior in a different way because of the distinction that happens. So the type class would be more a way to give a template of a structure. So it would be closer to an abstract based class on C++, I think. So like you implement the beginning, let's say, and then each time that you create an instance is when you create an instance for a type class on Haskell, is like you're creating a different implementation of that template. So it is, in a way, is very similar to a normal class because you are implementing a structure. You are implementing a data, like the ways to manipulate the data structures and behavior, which is functions. So you're implementing new data structures inside because you're gonna use the instance to implement different behavior for that data. So usually the way the pattern that I think is gonna follow or that is gonna be implemented the most is you're gonna have a algebraic data type, which is the data construct, the data keyword, which allows you to use either type constructors or data constructors to create new types. So you're gonna use that combined with a type class. So when you create the instance, you're defining the behavior for that template based on the type that you have. It's kind of like merging the template with the class, let's say, like the on the concept point of view.
Type constructors, e.g. maybe, can encode kinds greater than that have no direct analog in C++. Is a data constructor just a built-in type? No, a data constructor is not just a built-in type, but a mechanism for creating values of a user-defined type. For example, Haskell copy coded data foo equals to bar in bar string. Here, bar and bars are data constructors that create values of type foo, e.g. bar 5 foo. Contrast this with a built-in type like int in Haskell, which is predefined by the language. 5. Key differences between Haskell and C. Concept Haskell type constructor template for creating types. Maybe a template. Class template less than class TGT data. Constructor constructs values of a type just 5. Class. Constructors foo and x times types of types greater than no explicit notion in C separation clear. Distinction between type and value levels. Blurred distinction. Classes and types overlap. 6. Conclusion. In C, a class defines a type, and templates allow for generic types. However, the type level abstraction is less explicit compared to Haskell. In Haskell, the distinction between type constructors and data constructors reflects its strong type system and functional design. The main philosophical difference is that Haskell separates type level programming from value level programming, while C++ blends them. These concepts highlight the expressiveness of type theory in Haskell and the practical object-oriented design of C. Both paradigms have their strengths depending on the problem being solved.
This is the stuff that I'm struggling to understand. It's like because when you talk about type, in my mind, because of the time that I spent on C++, I immediately associate with the behavior. So like what it means to have a type for me is the change that's gonna happen on the way you deal with the structure of the data. Like how do you organize the data, the memory? That's what a type is. So I guess like this is the core of the thing that's is confusing. It's like the what is because if you think about it, like in any language you're gonna have built-in types, but the built-in types are considered can be considered as data in the way you think about it. It's like for example you have integer, you have char, so like a type on C++ would be the combination of the built-in types, and the value would be considered the built-in types. That's kind of how I was thinking, but I think it is not. It doesn't work like this. Because you also have the concept of R value and L value. So R value would be like the actual value you get, and the L value is the value of the address of the data. So this is the reason why I asked this question here. I think that the main point of confusion is on the distinction of what exactly is a value and what exactly is a type.
Which is typically 263 to 1. In programming and type theory, types and values represent different aspects of data. Here's a breakdown of the distinctions and how a string would fit into them. 1. Types against values. Types A type defines the kind of data that can be held or manipulated. It describes what kind of thing a value is and what operations can be performed on it. Types act as abstract descriptions of how data is structured and what behaviors, functions, methods, etc. can be applied to it. Examples: C int, std string, my class are types. In Haskell, int, string, maybe a are types I. Type is something you use to classify values. Values a value represents actual data in the program. It is an instance of a type. Values are the concrete entities that occupy memory during program execution and hold the actual data. Examples in C, an integer, hello a string, and std vector less than greater than 1, 2, 3 a vector of integers or values in Haskell. 5 int, hello string, and just 3 maybe int are values a. Value is a piece of data that conforms to a given type. 2 string, value or type. The answer depends on the context. As a type, a string type refers to the concept or structure that represents strings. In C, the std string type is the type of string values. It defines the operations you can perform on strings, like concatenation or length. In Haskell, strings is a type representing a list of characters, i.e. genres. A value, a string value refers to an actual string of characters, like hello world or 12,345 in. C hello is a string value of type std string in. Haskell, hello is a string value of type string. Thus strings can be both types defining what strings are and values actual string data. The distinction comes from whether you're talking about the type of data, e.g. std string or string, or the actual data itself, e.g. hello or world. 3. Examples of types and values. Type C int, double std string, my class Haskell, int bool, maybe a list of a string which is char in Haskell Java, int string my class value C. Value of type int, hello value of type std string, std vector less than greater than 1, 2, 3. Value of type std vector less than greater than. Haskell 5 in value of type int, hello string value of type string, just 3. Maybe in value of type maybe in Java 42. Hello new my class. 4. How this distinction appears in programming languages. In C types like int, std string, float are types that specify the kind of data a variable can hold. Actual content of variables such as 42 or hello are values. The distinction is easy to see in the type declarations. TPP copy code in x equal to 5. Int is the type. 5 feet is the value std string name equal to Alice. std string is the type. Alice is the value in Haskell and string of types. The values are written as Haskell copy code x equal to 5. Int is the type. 5 is the value name equal to Alice. String is the type. Alice is the value. This allows the clear distinction between the type level, which you can think of as a blueprint, and the value level, which is the actual data. 5. Why is this distinction important? Type level types provide the structure and rules for how values behave. Types can define what operations are possible on values. For example, a string type may support operations like concatenation or substring extraction, while an int may support arithmetic operations in statically typed languages like C++ or Haskell. Types are important because they allow the compiler to perform type checking, ensuring that values are used correctly. Value level values are the concrete data that exist in memory. They are what a program manipulates during execution. Manipulation of values is what the program computes. By having a type system, you ensure that values are manipulated in ways that are consistent with their type, e.g. you can't add a string and an integer unless the type system allows that operation. The type system thus guides how values can interact and helps ensure correctness in programs. Summary of key differences. Types define the structure and operations on data, specifying what kind of thing a value is. Values are actual data that conform to a type, representing concrete instances of data in memory. String can be both a type defining what a string is and a value an actual string like hello. In this context, a string is a type when referring to std, string C or string Haskell, and it is a value when it represents an actual string such as hello.
This is the last question that I'm gonna ask, and then I'm gonna stop streaming. So I'm going to off stream. I'm going to search more for content. So I'm gonna maybe I'll go back to VS Code if I see that this path seems to be harder. Obviously, I want to find the easiest way. Like the main thing that I'm trying to do now is to figure out how they implement the optimizations to be able to load large directories without taking a massive amount of time. And I kind of already have an idea of how to do this, like I said in the beginning of the stream today, where like it's probably just implementing like breadth-first search and then emitting a signal from the server class to the client after a certain amount of time. And then after that amount of time is passed, you continue to load everything on the background. And then you load things based on user interaction. So I think that all the optimizations are based on that probably. And here I assume that what they implement to be able to scroll through the files is something like a window where only the data that is visible is loaded, and then on the background they have a way to either like to change the data that is being displayed based on the interaction, and either they delete and add, but I think that most likely they just cache after they load everything in the first time, and then they have a queue or something that determines like how much you show, so that it's not very slow to scroll through the data. But I think it makes more sense to try to understand or try to look for from one example, a search like the best example that I can find that is closer to what I'm trying to do, and then try to see if it is relatively easy to understand how they implement it, because obviously they face the same challenges and they probably like there are unknowns that I might be able to clarify by looking to their solution first. Then it's only if I see that it's gonna take a massive amount of time to understand how they did it that I'm going to just implement what I'm thinking in my mind right now. And if I am able to understand how they created here or the optimizations that they implemented, then obviously what I'm gonna try to do is just extract the stuff that they do and incorporate on the classes that I have on Godot there. So I'm probably gonna focus on trying to find operational system or a kernel implementation or the GUI parts of the operational system that implements a file system GUI, so I can understand how or think about the best way to implement the optimizations on my stuff there. And I think that VS Code is most likely probably going to be like it's harder to translate into the stuff that I'm trying to do because of the framework that they use. So it's probably better, but it might not be depending on how complex it's going to be. Because there might be a bunch of other stuff involved on the operational system that I'm not aware yet. That makes it harder to translate into the stuff that I'm doing than VS Code would be, but I assume that the operational system implementation is going to be closer to what I'm trying to do there.
You're asking about some very foundational concepts in type theory, and it's great to explore these distinctions. Let's clarify the differences between type constructors and value constructors, and address your questions about C++ templates. 1. Type constructors against value constructors. Type constructor. Type constructor is something that generates new types from other types. It is a function at the type level that takes one or more types and returns a new type. Got examples in Haskell. The maybe type constructor takes a type A and produces a new type maybe A. The kind of maybe is greater than because it takes one type and returns another. Haskell copy coded data maybe equal to nothing. Just a maybe is a type constructor. Maybe int is a new type. A type for values that can either be nothing or just an int and C. A template is essentially a type constructor that allows you to generate new types based on a given type parameter. For example, std vectorless and greater than is a template that constructs a type std vectorless and greater than std vectorless and float greater than, etc. Depending on the type T you specify. Value constructor. A value constructor is something that creates values of a type. It is a function at the value level that takes arguments and constructs an actual value of a type. Got examples in Haskell. A data constructor like just or nothing is a value constructor. Haskell copy coded just 5. Maybe and just is a value constructor. 5 feet is the value. In C, a constructor within a class is a value constructor. It creates instances of a class which are values of the class type. CPP copy code class foo public. Foo index constructor creates an instance of foo. Foo 42. Foo is a value and its constructor is the value constructor. 2. C++ templates type constructor or value constructor. C++ templates as type constructors. You're correct in assuming that C++ templates are more like type constructors. A template allows you to define generic types that depend on a type parameter. CPP copy coded template less than AP name T greater than class my class is T value. My class less than greater than is a type constructor because it creates types like my class less than, in greater than, or my class less than double greater than based on the type T. The template itself is a type level abstraction that takes a type like int double and produces a new type like my class less than and greater than. My class less than like values always have types. Yes, values always have types, but the type of a value can be generated dynamically using templates. A value itself is concrete data, but the type of that value is determined by the type of the class or template that generated it. When you instantiate a template, you're creating a type, and then you can create values of that type. For example, CPP copy coded template less than AP name T greater than class box public. T value, box of v, value v, constructor is a value constructor, box less than and greater than bone 42, box less than and greater than is the type, 42 is the value box less than or greater than b2 3.14, box less than or greater than is the type, 3. Here, box less than and greater than and box less than or greater than are types, and constructor box of v is a value constructor that creates values of these types. 3. How can we have a value constructor if a value always has a type? This is a very insightful question. Here's how to understand this. Values are always associated with types, but the creation of values often involves a value constructor. A value constructor does not change the fact that a value. 3. How can we have a value constructor if a value always has a type? This is a very insightful question. Here's how to understand this. Values are always associated with types, but the creation of values often involves a value constructor. A value constructor does not change the fact that a value must have a type. It simply defines how you create a specific instance value of a particular type in. See, when you instantiate a class template like box less than and greater than, the template is a type constructor that defines a new type box less than and greater than. The constructor, e.g., box of v, is a value constructor that creates an actual instance value of that type. Even though the value is created by a constructor, it still has a defined type box less than and greater than in this case. In Haskell, a data constructor like just creates a value of a type. Haskell copy code just 3, maybe int. Here, just is the value constructor, and maybe int is the type. The value just 3 is of type maybe int, and the constructor just defines how to create that value. 4. The relationship between type constructors and value constructors. Type constructors and value constructors are related but exist at different levels of abstraction. Type constructors define how to create new types. Value constructors define how to create actual values of those types. For example, in Haskell, you have Haskell copy coded data. Maybe a equal to nothing, just a maybe is the type constructor, as it takes a type argument a and produces a new type, maybe int, maybe string, etc. nothing. And just are value constructors, as they create values of the maybe type, e.g. just 5, maybe int. Similarly, in CCPP key copy coded template less than name t greater than class box public t value box of v value v. Constructor value constructor creates an instance of box less than greater than is the type constructor, and box less than and greater than box less than double greater than are specific types. Constructor box of v is the value constructor that creates instances values of box less than and greater than or box less than double greater than. 5. Summary. Type constructors define new types based on other types. In C templates like template less than class t greater than class my class are type constructors. Value constructors define how to create values instances of types. In C class constructors like my class of v are value constructors. Values always have types. Every value has a type, but a type constructor is responsible for defining that type. A value constructor is responsible for creating a concrete value of that type.
So I think that this is the thing that is confusing me the most is like how do you know? Because the way that I'm thinking about it on Haskell is that the when you have these letters here is as if they're gonna be generic templates on C++. So it's like just a generic thing that can be replaced with anything. But the question is then like what does it mean to have a value that is constructed from that template? Because if you don't have any specification, then can the value be anything you want? And then what does it mean for the value to be anything you want?
You're almost there with your understanding, which is typically 263, 63 to 1. ChatGPT Shiryu said, what exactly is the difference between a type and a class? For example, on C++, when using templates like template less than class t greater than or class foo, the class can be considered a type, but how does it differ from the type on a template? Where exactly is the distinction drawn by the compiler as well, and how?
When they changed ChatGPT, it fucked up the speech writing.
You're almost there with your understanding. Let's walk through the example and clarify the distinction between type constructors, data constructors, and the rules that determine how values can be constructed from a type. Understanding the example, your example in Haskell is almost like this. Haskell copy coded data hello A equal to hello nothing A. However, there seems to be a small misunderstanding in the syntax here. In Haskell, data constructors are defined more explicitly, and nothing is used as a constructor for the maybe type. Let's reframe your example to be syntactically correct and easier to follow. Haskell copy coded data hello A equal to hello nothing hello A. Now let's break it down. Hello is a type constructor, hello A is a type constructor. It takes a type e.g. int, string, bool, and produces a new type. The kind of hello is greater than, meaning it takes one type argument like int or string and produces a new type. Hello A represents a type that is parameterized by A, and A could be any type. Hello is also a data constructor. The second part of your code, hello A, is a data constructor, which is used to create values of the type hello A in this case. Hello A is a constructor that takes an argument of type A and creates a value of the type hello A. So hello 42 would be a valid value of type hello int, and hello world would be a valid value of type hello string. Nothing is a data constructor. Nothing is a data constructor that is part of the maybe type in Haskell. It's used to represent the absence of a value, and its type is maybe A. If you want to use nothing in your hello type, you would need to change your data definition to something like Haskell copy coded data hello A equal to hello maybe A in this case. Hello maybe A means that hello can either contain nothing indicating no value, or a value of type maybe A, which could be either just A or nothing. What determines whether a value can be constructed from a type? To understand what determines whether or not a value can be constructed from a type, it's important to look at the type constructor and the data constructors. Type constructor defines the structure of a type, but doesn't tell you how to create actual values. It simply establishes the kinds of values it can contain. In your example, hello A is a type constructor that produces a type that could hold a value of type A. Data constructors define how to create actual values of a type in your case. Hello is a data constructor that takes a value of type A and returns a value of type hello A. Nothing is a data constructor that produces a value of type maybe A, not a value of type hello. So in this case, if you define data hello A equal to hello A, then you can construct a value like hello 42, hello int, or hello world, hello string. You cannot construct hello using nothing directly unless nothing is part of the data constructors for hello. For example, if hello was defined as data hello A equal to hello maybe A, then you could construct hello nothing, which would be of type hello maybe A. In your example, if you had the following Haskell copy coded data hello A equal to hello nothing A, this would be problematic because the type constructor hello expects a value of type A, and nothing is not a value of type A. Nothing is of type maybe A, so you cannot directly use nothing in a data constructor that expects a value of type A. So if you wanted hello to contain nothing, you would need to adjust your data definition like this: Haskell copy coded data hello A equal to hello maybe A. This would allow you to create values like hello just 42, hello int, hello nothing, hello int. This indicates no value of type int is present. Summary of the key points: type constructors like hello define new types that can take other types as parameters. Hello A creates a type that holds a value of type A. Data constructors like hello and nothing define how to create values of those types. The type of a value is determined by the type constructor, and the data constructor creates an actual value of that type in your example. A is not directly a data constructor, it's a type variable. The data constructor hello takes a value of type A and creates a hello value. To include nothing, it should be part of the type structure like maybe A. Thus, whether or not a value can be constructed depends on the data constructors defined for that type and the types involved in those constructors.
It looks like it's not gonna work here. I'm just gonna stop. And this is the last question that I'm gonna read here.
In most programming languages, especially statically typed ones like Haskell or C, every value has a type, and this is essential for ensuring correctness and predictability in a language. However, the way types are assigned and inferred can vary, and there are some nuanced cases where the relationship between values and types can seem more flexible. Let's break this down in the context of different programming paradigms. 1. Statically typed languages, e.g. Haskell, C, Java. In statically typed languages, every value has a type, and this type is determined at compile time. Here's why. Haskell. Every expression in Haskell is evaluated to a value, and that value is associated with a specific type. For example, 42 has the type int, and hello has the type string. The type system ensures that values adhere to their types, preventing errors related to type mismatches. Haskell's type inference allows you to avoid explicitly specifying the type in many cases, but the type is still implicitly inferred and associated with the value. Example: Haskell copy code x equal to 42. Int x is explicitly of type int y equal to hello. Y is inferred to be of type string C and C. Every value is also tied to a type. This can be explicitly declared or in some cases inferred, such as with auto, but a type is still associated with every value. Example: CPPP copy code int x equal to 42. X has the type int auto y equal to 42. Y is deduced to be of type int. In both of these cases, values cannot exist without types because the type system enforces this rule for correctness. 2. Dynamically typed languages, e.g. Python, JavaScript. In dynamically typed languages, values still have types, but the type is determined at runtime rather than compile time. Python. In Python, every value has a type, but you don't need to explicitly declare it. The type is inferred at runtime when the value is assigned. Example: Python copy code x equal to 42 hashtag x is of type int y equal to hello hashtag y is of type str. JavaScript. Similarly, JavaScript variables are dynamically typed. The type of a value is not fixed at the time of declaration, but every value has a type at runtime. Example: JavaScript copy code let x equal to 42. X is a number, let y equal to hello. In these languages, the value is always associated with a type, but the type isn't determined until runtime. However, the notion that a value can exist without a type is impossible, since the type is always inferred dynamically. 3. Theoretical context, e.g. untyped lambda calculus. In theoretical contexts, such as untyped lambda calculus, values can exist without a fixed type. This is different from practical programming languages and more of a theoretical construct. The idea of untyped values arises in lambda calculus, where variables can be used without assigning them specific types. Untyped lambda calculus. The lambda calculus is often used to study computation without specific concern for types. Expressions in untyped lambda calculus are just function applications and abstractions, and their evaluation doesn't require explicit typing. The idea is that the value itself, the term, is independent of any type. Example: in untyped lambda calculus, lambda copy code lambda x dot a function that returns its input. No type is assigned to. In this context, you might say that there are values like terms in lambda calculus that don't have explicit types. However, types can still be inferred or assigned, but the system doesn't enforce them. 4. Null or undefined values. In some programming languages, there are special values like null or undefined that can be considered to have no value, but they still have types. JavaScript, the value null has its own type, object, and undefined is of type undefined. While you can assign null or undefined to variables, they still have a type. Example: JavaScript copy code let x equal to null, x has the type object, which is typically 263 to 1. 5. The role of types in programming languages. In most programming languages, the purpose of types is to ensure correctness by specifying what kinds of values are allowed in a given context, prevent errors related to type mismatches, which could lead to bugs or undefined behavior, provide clarity, and help tools like IDs and type checkers understand how code should behave. Thus, in practical programming, whether statically or dynamically typed, values will always have types, and the notion of a value without a type doesn't really apply. Even in languages with dynamic typing, types exist at runtime and govern the behavior of the program. Conclusion: in summary, in most programming languages, values always have types, either inferred or explicitly declared. Even in dynamically typed languages, the type is associated with the value at runtime. The only exception is in theoretical systems like untyped lambda calculus, where values may not have a fixed type, but these are abstract constructs rather than practical programming languages. So no, a value cannot exist without a type in practical programming languages. However, in theoretical systems or languages with no type system like untyped lambda calculus, values may exist without a specified type.
Yeah, so I do understand how it works, but it's still not very clear to me how to think about the distinction about type classes in Haskell and normal classes on C++. But I do understand like when you're creating the type on the type constructor with the type constructor on Haskell, it's like you're creating an intersection of sets. Just like you're creating a new type by making other types together, let's say. And when you have a value constructor, you're just assigning a type to that value. And because it's generic, it means you can have any type that you want for that constructor. But it's still very confusing to me. I can't quite figure out a way to make the distinction very clear of how it works. On the in practice, when you're building programs, what is the main difference on the way that the Haskell is gonna deal, the way that you build things with Haskell, and the way that you build with C++? The main thing that is confusing is this relationship between the normal classes and the template classes. So I'm gonna stop streaming now. I'm gonna continue to. I'm gonna ask more questions here, try to see if I can clarify, and then I'm gonna focus more on. I'm gonna try to figure out. I'm gonna see. Probably just ask more questions to GPT and Perplexity to see if this is really the best one to focus. But if it is, then I'm probably just gonna focus on this. I'm gonna try to understand the operating system, file systems, optimizations, and then see if I can implement their optimizations on my stuff there instead of studying VS Code. So see you